Advent of code, day 3 in 3, 2, 1. One elf has the important job of loading all of the rucksacks with supplies for the jungle journey. Unfortunately, that elf didn't quite follow the packing instructions, and so a few items now need to be rearranged. Each rucksack has 2 large compartments. All items of a given type are meant to go into exactly one of the 2 compartments. The elf that did the packing failed to follow this rule for exactly 1 item type per rucksack. Interesting. The elves have made a list of all the items currently in each rucksack, your puzzle input, but they need your help finding the errors. Every item type is identified by a single lowercase or uppercase letter. A and a capital A refer to different types of items. The list of items for each rucksack is given as characters all on a single line. A given rucksack always has the same number of items in each of its 2 compartments, so the first half of the characters represent items in the first compartment, while the second half of the characters represent items in the second compartment. Suppose you have the following list of contents from 6 rucksacks. Got it. The only item type that appears in both rucksacks is the lowercase p. 1 item type per rucksack for exactly 1 per rucksack. Okay. To help prioritize item rearrangement, every item type can be converted to a priority. In the above example, the priority of the item type that appears in both compartments is 16 P, L, PV. Okay, some of these is 157. Some of the priorities. Cars. Car list. Oops. To list. String to list. Okay, perfect. Let shared item rucksack equals let num items equals list dot items equals rucksack list dot string dot to list rucksack length items let bag 1 bag 2 partition I want, let's see. Where is take? Okay, so I can do bag 1 equals list dot take items num items over 2 and let bag 2 equals list dot drop items num items over 2 in let hash set dot of list A, B, C. See it get in my tummy. OCaml real world sets. Set. Set.ofList module car. Cool. Set.ofList. Okay, that's how this syntax works. Car.hash set.ofList in let common item equals OCaml core hash set. Why did these versions, why are they so off? And then priority. Shared item is going to be intersection. Inter. Hash set dot inter bag1 bag2 hash set dot to list dot head xn. And then let priority of item equals OCaml core car. All right, what do I have in car? Why is this website so slow? If car is lowercase item, then car.to int item. Let a lowercase offset equals car.to int of a. Item else. And now I can do let sum priorities equals list dot sum module int f fun l priority shared item L priority in print end line part 1 int dot toString sum priorities. It's not very happy. Oh, maybe it is. All right, if I wrote all of that and it just works first try, I'm feeling pretty good about myself. Nope. Oh, that's just because I forgot to do this bit. I forgot to pass lines in as an argument. And does it work? I think so. What is drop? Okay. End line, rucksack, items, bag 1, hash set, how is that? Why isn't that a function? List toString. Where's toString? car.toString. Oh. Does that work? Oh. Enter. Oh, that's why. And now will it work? I think it'll work. No, too low. Priority is 1. Priority Z. Oh. All right, that will fix that. There we go. Yay. Part 2, as you finish identifying the misplaced items, the elves come to you with another issue. Elves are divided into groups of 3. Every elf carries a badge that identifies their group. For efficiency within each group of 3 elves, the badge is the only item type carried by all 3 elves. That is, if a group's badge is item type B, then all 3 elves will have item type B somewhere in their rucksack. And at most 2 of the elves will be carrying any other item type. The problem is that someone forgot to put this year's updated authenticity sticker on the badges. All of the badges need to be pulled out of the rucksack so the new authenticity stickers can be attached. Additionally, nobody wrote down which item type corresponds to each group's badges. The only way to tell which item type is the right one is by finding the one item type that is common between all 3 elves in each group. Every set of 3 lines in your list corresponds to a single group, but each group can have a different badge item type. So in the above example, the first group's rucksacks are the first 3 lines. The second group's rucksacks are the next 3. In the first group, the only item type that appears in all 3 rucksacks is lowercase r. In the second group, their badge item type must be Z. Okay, some of the priorities of these item types. Transpose, intersperse, int. Min element, nth, split n. Can I use split n do you count range? No, that's not what I want. But I think I can use split n. What in groups of n list n equals in groups of n, l, n groups equals match L we can do if list dot is empty, then groups else let next group equals list dot take L n rest list dot drop L n in groups of n rest and next group groups. In let grouped equals in groups of n, l, n. Let's see. What are they? Elf groups? Elf groups equals in groups of n lines 3. Let some, what is it called? Badges equals list dot sum module int f equals let badge priority group equals let init equals car dot hash set dot create in let badge equals badge items equals list dot fold group init f hash set dot merge union. Fold. Oh, is it reduce that doesn't take a... let items equals list dot map group f l car dot hash set of list string dot to list. In bag items, badge items equals reduce priority of health groups equals F badge priority in list iter group F print end line print end line group let and then print end line common an item this is car.to string badge items reduce health groups. Did it work? Did it work? I think so. Yeah! Day 3, let's go! Alright, what do we do here? So we get our input, and then we have a couple of functions. First, for part 1, we need to, for part 1, we need to get the shared item in a rucksack and then print out, get its priority, and then sum those up. And so we just break the string into a list of characters. Bag 1 is the first half of those characters. We take those items. This second bag is the second half of those characters, which we just do drop. And then we create a hash set from those, and then we intersect them, convert it to a list, get the first one out. Let's see, is there another version of that set? Wait, is this hash set? Looks like these are different things. I'm using hash set. So I can iterate over them for all, find, to list, to array, add, remove, filter, union. All right. So this is the, so I convert it, take the intersection, convert it to a list, and then I get the first element of that list. And then the priority, I basically do some, get the offsets from lowercase a, check if it's lowercase, then remove the offset from lowercase a. If it's uppercase, remove the offset from uppercase a, and then add 26. I forgot to do that the first time. And so I do that. Sum up all the, for every line, get the shared item, take its priority, sum up those values. Then for the second bit, for the second thing, I wrote this in groups of n function, where this is a recursive function where I accumulate the groups by doing take and drop again. And so I get the next group, which is taking the next 3 elements, and then the rest is everything after that. And then I add that next group to my list of groups. And then I recurse with that accumulator thing. And then I have to reverse it at the end. I can print out this stuff. So then for the badge priority, for each group, line in the group, I can print out that too. I map all of them to take every list, convert it to a string of cars, and then make a car set out of it, and then I reduce them with intersection, and then I convert that to a list, take the head of it, and then priority. So alternatively, could implement this as list.map. Group list.map f string.to list list.map car.hashset.of list list.reduce exception f hash set.enter hash set.toList list.head exin priority. And that solves it just as well. I think. Yeah, 2864. Cool.